using proton NMR spectroscopy to distinguish between these two compounds. So let's first look at this position right here. In both cases, the protons on this green position are going to show up at 2.2 because they are methylene and they're one away from a carbonyl. However, the ones that are here are going to show up as a triplet because they're going to be split by these orange ones right below. So this one will be a triplet, and this on the other side, this one is isolated, and so it'll be a singlet. So we can look at the 2.2, the peak that appears at 2.2, and see whether it's a triplet or a singlet. We could also look at this, the hydrogen, the protons attached to this carbon. Here we'll get a singlet at 4.2, and here on the right side we'll get a triplet because it'll be split by these protons right here. And this one will also be at 4.2 because it has the same, the ester group has the same effect on it. Okay, let's look at some more. This next one's going to be easier because to distinguish between the two A groups, this one will have 3 signals and this one has 6. So we've got one here, there's no carbons here, there'll be one here and one here, and these just repeat because the molecule has symmetry. The other molecule is going to have a signal here, 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 and here. On B, there will be, each compound has a singlet that occurs right from the protons at this position. Those are isolated, so that'll be a singlet. And it will be at 1.9. The singlet here, this is also a singlet. But it will be at 3.9. It starts as a 0.9, and we add 3 to it because of this ester that's right here. I guess I could write that out. All right. The next one, we can look at just the number of signals. One, that one's identical. So we're only going to have 2 signals on the left one. On the right one, we'll have 1, 2, 3 signals.